Hi, what we're going to look at now is reading the Z tables in that backward method that Alan was looking at. So let's look at an example. A test has a mean of 50 and a standard deviation of 10. Now, what mark do I need to be in the top 10%? So on our little graph, here's the top 10%. So what we're looking for is a Z score that will give us 10%. So instead of, as Alan was saying, instead of looking at the outside of the Z tables, we're going to look at the inside. So let's have a look at our Z tables here. Now we're looking at 10% and we're looking at the inside. So we want to find the Z score. Now 10% is here. This is 9.85%. This is 10.03%. So we're somewhere in between here, which is 1.28. And it's a little bit towards 9. So I'm going to say 1.281. Now, it's not too much of an issue, but I'm going to call it 1.281. So the Z score we want here is 1.281. So that's our Z score. So how do we find our mark? Well, we use the same formula. We know that the Z score equals my mark minus the mean divided by the standard deviation. So what does that tell us? That 1.281, which is the Z score, equals my mark minus the mean of 50, all divided by 10. And then we've got to use a little bit of equations to figure out how to get back. So we times by 10 to get 12.81 equals x minus 50. And then bring the 50 over. Instead of minusing 50, we can add 50 to get 62.81 equals x. So to get a score above 62.81 will put us in the top 10%. Now, as I said before, I estimated this 0.1. Suppose I'd estimated 0.2, what would have changed down here? This would have been 62.82. If I'd have estimated 0.3, 0.003, this would have changed to a 3. So it's a minimal amount of difference. And that's why Alan said that we just need to estimate these scores. Suppose we want to change this. What mark do I need to beat to stay out of the bottom 25? So now I'm not looking at getting the top 10. I'm looking at what mark do I need to stay out of the bottom 25. Now remember, the mean equals 50 and the standard deviation equals 10. Probably should write the standard deviation like that. So again, the first thing we want to do is find out the Z score. And we want a Z score of 25. So if we look at our table, and again, we're looking at the middle part of the table, we want a percentage of 25. This is 26, 29, 20%. Here is 25%. It's somewhere between 0.67 and 0.68. And it's about in the middle, so I'm going to say it's 0.675. So this Z score here would be 0.675. But remember the table, and it's something I've forgotten here, the table actually gives us the top part. So this Z score would be 0.675, but because of symmetry, we want the bottom 25%, so all that is going to be minus 0.675. So that gives us an idea of our Z score. And again, we can use the same sort of thing with equations. We know our Z score is minus 675, so minus 0.675 equals my score minus the mean, which was 50, divided by the standard deviation. And again, I can multiply. So minus 6.75 equals x minus 50. And then I can bring the 50 over and plus it to this to give 43.25 gives us our x. So to stay out of the bottom 25%, I need to score at least 43.25. Let's finish on this example. The mean of a test score is 60 and the standard deviation is 50. Between what two values between what two scores do the middle 60% of marks lie? So again, we can draw a very quick distribution diagram, and we want to know between what two marks is this going to give us 60%? Between this mark and this mark, that's the middle 60%. So that means that this percentage in here is 20%, and this percentage in here is 20%. So again, that's what we're going to be looking at when we look up our Z scores. We're going to be looking at a percentage of 20% to find out that Z score. So let's have a look at 20%. So on our Z score tables, where is 20%, 15%, 17%, 20%? So we're getting closer. Here's 20.5% and 19.77. So it's somewhere in between these two, which is 0.804. Sorry, 0.84. And we might make it 0.841. So this Z score here is going to be 0.841. And this Z score is going to be minus 0.841. And that will give us the middle 60%. So how do we find out these scores? We go back and we look at our Z score is 0.841 equals. And it's always the same. Remember that formula. And you will be given this. Z equals my score minus the mean divided by the standard deviation. And as Alan said, if you are not given it, it is on our Z score table anyway, up the top there. The Z score is your score minus the mean divided by the standard deviation. So we know that is 0.841. We want to find X. We know that the mean is 60 and the standard deviation is 15. And we can go from there. We take this 15 over. 15 times 0.841 equals X minus 60. And then we can take this 60 over to find out our top score. So it would be 60 plus 15 times 0.841. That would give us our top score. And if we wanted to know the bottom score is going to be exactly the same, except it's going to be 60 minus 15 times 0.841 equals. And they are going to give you the two scores that you have to be between to be in the middle 60%. Hopefully that's explained a little bit more about how we read the tables backwards, the way Alan was doing. Thanks.